The ML system requires around 72 hours of learning time.
Okay.
There are periodic events that happen in environments that it's not magic. If we don't see it, we don't know that it should be allowed. So 72 hours typically gets us to around 98% confidence on our policy sets.
Lovely.
And confidence is an important point. How can a machine learning system know if it's right? The way you know that it's right, and I'll get to your question momentarily, is if I take a bunch of data, and I've got 100% of the data that I've witnessed, and I used all of that data to create policy sets, you could never test it, because everything would always effectively be correct. Mm-hmm. So what we do is we actually take this data, and we only look at the newest 90%. We don't look at the oldest 90%. We don't look at the newest 90%. And the ML system builds its policies, and to create a confidence score, it takes the newest 10% of data and bounces it against the policy set that it created to basically say, what would I do in the face of unobserved behaviors in the environment? Does the policy set actually stand up to this effectively? And so the point that I'm getting at to tie it to your question is this. When we go into an environment, a customer deploys us to the environment that they want to do the POC testing in. That's something that they do on their own. It's very simple. It's just a scripted operation or through their CM system. After that, you go through this learning period, which is just passive time. And when they get back into the environment, what they see is this. This was like Active Directory right here. If we go to host segment details, you can see that it was machine learned, but it's now user managed. This object would actually appear in the list like these. When the user first logs in, they see a list of these ML host segment objects. The question is, what do they want to segment? And so literally what they do is they simply ask a question. They come in and they say, show all host segments that have hosts AD and O1 and O2, or they can use an expression to describe a naming convention, and it will come up with all of the objects that contain those systems. So one of them that came up was Active Directory, which I had renamed to Active Directory. And once that's there, what it tells you is what its potential for protection is. It gives you some stats, which we'll get into right now. The user sees this object, they give it a name, and then they click on this guy. This is an active scan that happens on a continuous basis. And what it's doing is discovering all of the possible network pathways to the selected target, we call it. And right here you can see there's 2,030 possible pathways to Active Directory that we can see. We can determine what is actually communicating based on its software identity. We see those connections. We run it against our reputation service. We say which of these are actually needed. And then we come up with this, which is 997 of them are actually needed, which means that we can get rid of 1,030 of these connections. So the user sees that, and literally what they do, and I've already done this at the beginning of the presentation, they come here and they click auto segment. So what is that actually doing? Well, what ML was doing in the background while you were doing other things in your day was it was creating the policy set. So the policy set, right now what you're looking at is enforced policies, simulated policies, and then you can click recommended policies. And recommended policies, we'll just find something. In fact, we can just go into protect. We'll just look at Active Directory. So we'll change to Active Directory here. Look at Policy Builder.
I'm sorry, I think I may have missed something. When you say Active Directory, you're looking at authentication traffic from Active Directory.
I'm looking at all communications to or from Active Directory that have occurred. Okay. And what we're doing is collecting all of those paths, identifying what the software is on either side of the connection, building out the policies behind the scene, and when I click auto segment, what it literally did was take that list of ML recommended policies and put them into effect with a simulated block.
Can I throw down into those recommendations to see what type of communication?
That's what we're going to do right now.
All right.
Yeah, so let's look at...
And that, just to clarify, that's specifically, you have the agent on the domain controllers, that's talking with the cloud, and then communicating.
Yeah, so you've deployed our software through AD wherever it's going to go, wherever your AD touches, or you've used your configuration management system to put it wherever it goes. It collects this telemetry data. The ML system starts analyzing it, doing reputation scoring, building the policies behind the scenes. It correctly identifies the groupings of systems. So it identified that AD01 and AD02 were AD servers. It grouped them together. The only thing it couldn't do was give it a name that you knew, right? I can't come up with a name that is meaningful to you from a business object perspective. Like if you had an ERP system, how would I know to call it erp.company.com? You just wouldn't know. So we give them this sort of terse naming. You say, well, I want to protect Active Directory. You search for it. It comes up with the object. You name it Active Directory. From that point forward, all you're doing is clicking auto segment. And auto segment has zero risk to you. And this is why.
So is this an on-site machine learning or cloud-based machine learning?
Cloud-based. Yep.
Can it be on-site?
It can. We've really have not had a need to do that. Typically what we'll do is segment off a portion of the AWS environment for a specific customer. And yeah, please.
That all depends on how AWS does its security, not necessarily you.
Yep.
And there's a lot of problems with AWS security itself. So having an on-site version for certain types of customers?
There are certain types of customers. So for instance, there was a nuclear power plant that because we weren't going to put it into a rack and stack in some data center in their environment, that's a no-go. But I mean, look no further than CrowdStrike. I mean, it's difficult to argue against the success of CrowdStrike, and they don't do on-prem at all.
Are you looking for FedRAMP certification?
No, I'm not. We've actually had success getting exceptions put in place for certain three-letter agencies. It's certainly not something that they would all entertain, but there are certain ones that would.
I have another question. Thank you. My 2 questions, I can't remember what the first one was, but I will probably remember after I ask the second. I obviously live in the UK, which has to deal with GDPR quite a lot. And then your comment about using AWS. Can we choose like...
Regions, yes.
Yeah, okay.
Yeah,
That's quite specific.
It's very important,
yeah.
Right.
And also, if I have, for example, a global office, would I expect that you would say, well, each kind of, each country or something, each office has their own, or would I spread it against multiple?
I'm sorry, I don't quite understand.
Like if it's a global company that's got like headquarters in the UK, it's got Germany and the US, for example.
Oh, I get it.
Yeah, would I be doing this?
We can provision either a site, we call them site IDs.
Yeah.
I can provision a site ID that would cover all of those regions.
Yeah.
Or if you wanted a site ID for each individual region.
What about in the case of my example, I can't have any data going to the US office because it's EU, yeah? But I want something that works the same for all of it. Would it have to be 2 provisions, or would it?
Well,
I would probably...
On that point, how much of this would be data that would be impacting user data as opposed to just being like Active Directory underlying authentication?
Any Active Directory is actually user data.
But also, I'm meaning more like once you've built those rules, my data is not going to be flowing anyway. It's going to.
That's right. Yeah? That's right. Yeah. So what I would recommend in that scenario specifically is actually breaking it into 2 different site IDs. We would provision one site ID into a region that had the appropriate data sovereignty, and then another site ID into the typical region. I think you said that it was split between UK and US or something like that.
Which is pretty typical of my clients.
Yeah.
The other, sorry.
I was going to say, so when you have the multiple site IDs, how is it administratively? Is it
administratively, we don't do federation yet. So there is some friction introduced there in that you've got 2 administrative domains, and we don't at this time have something that sort of sits on top of it.
Centralizes it.
Yeah.
So you would have to theoretically label, if I want to label Active Directory in site A, I would then have to manually label Active Directory in site B as well?
Exactly.
Okay.
Yep.
And then, I just have one question quickly.
Is that something you're working on?
Oh, okay.
Or can you not say?
I'm really, I'm hesitant to go into details of things we have sort of coming in near term, just because it is a very competitive space.
Well, not only that, they have all the scripting mechanism. You can write your own.
Oh, you know what? That's a fantastic point.
I have
Yes.
another question. I have another.
That.
My other question is in regards to just, I mean, sorry if it's a silly question, but if I were to view this as like, how it says, like you said, it's got all these different other channels. Can I set that up in I want it to alert, almost like a detection or prevent, as in turn it?
Absolutely. This is a good segue into what I was going to show you.
And then
IPS versus strict enforcement.
Yeah, that's basically what
it's a great point.
And then the second part that's part of that is getting all of that data in my logging and monitoring software.
Yes.
Is it something that I would expect to have to customize all myself, do my own tagging, or do you have custom, like, actual built stuff that can work with other?
So getting this data fit into your model, it does require some work.
Okay.
It's as simple as that. You're going to have to put some sweat into mapping fields that are meaningful to you and doing the correlation that is useful to you.
And then
If you just want like yes/no answers that you can create events off of, that's very simple. If you want to do correlation across, let's say you wanted to map out communication pathways and see an event happen on host X and say what similar type of events happened on things that it has communicated with in n window of time, that is not straightforward. That requires a professional services at the end of the day.
Oh, professional. And you guys offer professional?
Oh, absolutely.
Okay.
Yeah.
And then going back to my original question about training, because I see in my experience, typically, if I were to, for example, sell this product, they would expect, typically they'll be like, okay, you can deploy it, teach us how to use it. I don't care if we have to pay for a certification, but we need that available to walk us through.
We include training in virtually every one of our contracts that's mid-market or larger. If it's a smaller organization, it just doesn't quite fit because we'll go on-site. So there's actually a company right down the road that I'm going to meet after this where we rolled in 3 days worth of training into the actual cost of the solution. And our support service, given that we're a startup, our support isn't sort of break fix. It's if you come to us and you say, I did this, and I think there might be a better way to do it. I'm not quite sure how. Can you show me how? Everyone that does support at Edgewise is incredibly skilled at what we do. And they're not told to just say, sorry, that's a perfect. No, of course not. That's absurd. We're going to help you fix it. We're going to help you do whatever you want to do and show you how to accomplish the outcome.
Okay, and does that include, like, if you have, for example, a lot of the software that I've worked with in the past, when I'm dealing with those kind of scenarios, because there's always a client that has a very specific need that I'm going to have to build something for, which is fine, but I then can talk back to the company and maybe put it in their community documents, or do you have that sort of?
We do. We actually have community documentation in two ways.
Okay.
One is actually feedback for the product. So you might be familiar with AHA. So AHA Ideas Portal, which is a way for managing product capabilities and whatnot, give direct feedback from customers. If you look at our solution and you say, wouldn't it be great if? Well, you don't have to stop there. You just type it into the field and hit submit. And we aggregate all of the community's feedback on where we should take the product, and everybody can see everybody else's. So you're not just, dropping it into the void and, there's 20 other duplicates. You can sort of thumbs up somebody else's idea that matches what you want. From a community documentation perspective, it's a wiki-driven sort of interface, and not everyone, but certain people can actually build and contribute content. We don't want everyone just sort of building random pages because, being a librarian is incredibly time-consuming, it turns out.
So if you implemented this in an environment, you're taking what's already happening and building policy based on that. Do you automatically detect like the really bad things that are happening, like, for example, SMBv1. If that was in use, would you raise a red flag that I would then have to look at and say, why in the world is that in use?
It falls slightly outside the scope of what we're trying to accomplish. It's a great idea, and
So
I can see broader IPS capabilities that would include it, but today we don't do that.
So if I have a bad environment, you map the policy to that bad environment and say, that's actually good policy.
Well, actually, I would charge that what we're doing is in many ways protection against it. So, for instance, if SMBv1 was listening in the environment and you apply our protections and Petya gets dropped in the environment, well, it's interesting. Petya is just a piece of software that communicates SMBv1.
Correct.
Which is not approved software to communicate to the SMBv1 listener, which means it won't be able to communicate. The only thing that would be able to communicate with that SMBv1 listener is other operating system level SMBv1 clients, which are not Petya. And the point is, as far as zero trust is concerned, so divide this into two parts, microsegmentation, which we automate, and then zero trust, the identity verification part.
My concern is not that dropping something in. My concern is it's already in an environment and you don't know.
Yeah,
That's why we use the reputation scoring. It's 52 anti-malware scanners that take all of the identity properties, identify things that are known to be bad. And the other point is the multi-stage attack path. So let's actually look at one. So there's something bad in your environment, all right?
Always.
And I have not forgotten your question.
Yes.
We're going to go to connection viewer. We're going to look at database servers. We'll take LinOrderDB. We'll look at the Mongad system. And what we'll do is close the sidebar here, and we'll just take Pathfinder. And Pathfinder, you can see these numbers going up.
Zoom in just a little bit.
I may be able to.
I'm a bit blind.
Is that better?
Close enough.
I'm sorry. So let's take one of these objects. So you've got some unmanaged address space that talks to this node app, and ultimately it goes down to Mongad. And the point that I'm getting at here is if you lock down all intermediate points and all intermediate paths to the ultimate target, what you're saying is that an attacker may be at point A, and they have to get to point G to successfully compromise their ultimate target. The question is, sure, that there was a piece of malicious software that was not known to be bad, that was codified in policy, that got them from A to B. They still have to get to G. And by the way, if they've already gotten from A to G, then what exactly do you expect us to be doing here?
Automatically detect that you have bad software involved in anywhere.
That's why we use 52 anti-malware scanners, and we take every identity property and run it through them to identify the known bad stuff that is presently known.
And do you report on it?
Everything goes into monitor.
So here's my problem. You guys say monitor. No, I want alerts raised in my alert system, not yours. How do you raise alerts in other people's alert systems? Because I may have this massive environment that's already been running. That's what I use day in and day out. I can't go to the security teams that monitor that and tell them to change.
Exactly.
And I don't want to write my own code.
That is why we do these JSON exports.
Again, I don't want to have to write my own code.
You import it into your SIM and identify the event type that you want notifications on.
You just said I have to program it to import it into my SIM because my SIM has no clue about you. I'd rather you send it to my SIM on a regular basis.
Sure.
Because my SIM is the one I'm alerting on, and I need to raise collisions, I need to raise reputational issues. Because if you raise 53, and I have a bunch of software that raises all 53 alerts, I really want to know that's in my system.
Absolutely.
And I don't want to have to write anything
Generally
extra
speaking,
to do
though,
that.
I understand you don't want to do any coding, you don't want to do any integration work, most SIMs are pretty adept at importing from a file, and that's what we provide to you. A list of files that include those events that are highly structured, that you can literally say, event type equals, I want to know about it, done. End of story. It takes most people less than an hour to accomplish.
So then are you assuming that all of your customers already have the SIM in place and good to go?
Most customers, as far as security maturity is concerned, when they get to the point of microsegmentation, they have some centralized logging facility.
They should.
They should. Well, no, here's the thing. They should, and that's where the security folks come in. The management folks sometimes go, oh, it's microsegment, yeah, we need to stop this traffic, and they don't have a SIM in place.
Yep.
I've seen it a few times.
Yeah, operational people typically don't have SIMs. That's right.
So real world, your customers currently who are exporting and importing into a SIM, how frequently do they do those exports and imports? Like how many times a day?
Oh, I mean, it's typically just like a scheduled task that happens every hour. I mean, we dump data based on...
Okay, so 1 hour is way too long. I want less than 5 minutes, less than a minute, less than a microsecond of problem.
Yep, the data's right there.
I have a question.
That's why I want you guys to send it as soon as it happens. Or I want something to send it as soon as it happens.
I have a question about incident response. So if I've dealt with something, I know something's wrong, I would just go into, how would I investigate with that? Like, would I expect
that's a great
the
question.
responders going straight into this stack board?
So you can obviously do it through the ingested events in your SIM. You could do it through API. You can also go into this, and you could literally just say, I want to know about enforcement events. Okay. And in this case, I'm going to say, I want to know, let's say, directional information. I know what the target was. I could say target equals and just include an application, but I actually want to know directionally what it was after. So the target was LSAS. So what we're going to do is change our target to be from to, and we're going to say the to is LSAS. And let's say the from, what we know is it's one of these Linux systems. So we're going to select these guys, and I should actually look at last hour instead of last week. So this is all of the events that have occurred in that environment. So what you're looking at here is just a basic log, but when you expand it, it gets a little bit more interesting. You can actually see the host, the software, the address, the host, the software, the address, and port, and the policy that allowed that to go through, so that you know what needs to be modified if you want to change this behavior. If you want to change this behavior, it's fairly straightforward. You click on LSAS. And what that does is it jumps you to this view, it opens up the object, and it shows you the connectivity between it. And what we're going to do here is we're actually going to just modify what communicates to LSAS. So we can see here, never do live demos on hotel Wi-Fi.
So on your protection, are you saying you're as good or as better than Credential Guard? Because Credential Guard protects LSAS today at hardware level.
Yeah, I wouldn't get too caught up on the details. LSAS is one application out of 100,000 in a reasonably sized
The reason why I'm
environment.
saying LSAS is LSAS has extremely well-known attacks.
Yep. Yeah, and I think maybe what's worth highlighting, I want to make it clear what this protection actually does. So the best way to do that is to actually just show you. So what we're going to do here, I just want to actually make the point of what we do versus every other address-based control. If you're using firewalls, orchestrating a host-based firewall, using a next-gen firewall, you can piggyback through that, and the firewall has no idea. No idea. So this is something that I did about a year ago. It is recorded, but bear with me. So what we have here is a Linux system, an app server, and a remote database. The remote database is vulnerable to an O-Day. There is a leading next-gen firewall right in front of it. It's got application layer 7 protocol verification looking for MySQL protocol, and security profiles set to strict enforcement. So if I'm on this box and I do a netstat, because I want to piggyback. I don't want to scan your network. You'll figure it out. I see MySQL in the remote box. What I do is use Telnet client, Netcat, anything that can make a basic TCP connection, and I point it at the remote database. What the database gives back to me is the handshake for the protocol negotiation. We're trying to negotiate what version of the protocol we should be communicating. But when the firewall saw this, what it's doing is basic heuristic matching on the first 4,096 bytes of the connection. And it saw this string come back from the database and said, that looks like MySQL, and that's what the protocol requires, or the policy requires. Come on through. Now I know the version of the database. So what do I do with that? Well, I mean, all roads lead to Google, right? So MySQL 5510 O-Day remote code. The fourth one in the list is something called MySQL Jackpot. It is from 2012. There's been plenty of time to figure out how to protect against this. And what we're going to do is download it, point it at the database, and see what it does. So when we do that, there's two interesting things here. The first section above the reverse shell, what it's doing is taking a standard SQL query at the database to do a user-defined function call to load a shared object into the database's memory using that O-Day exploit, which then instantiates a reverse shell back here. And the firewall was good enough to detect the reverse shell. It saw it, and it said, that is definitely a reverse shell, and it stopped it. Because firewalls and NGFWs are really good at identifying and stopping really obvious things. But it had no idea that this O-Day had gone. And they have literally had years to fix this, but it goes right through. Because again, it's looking at the first 4,096 bytes of the connection. It says, well, that looks good, come on through. So what other approach might I use? I could use an administrative command, living off the land. MySQL admin. I point it at the remote database. I run a query to list all the usernames and passwords, which have some funny values in there. My co-founder has a great sense of humor. And again, the firewall saw it and let it go through because it was MySQL traffic between the right addresses and ports. So what do we do with Edgewise? What we do is we come in here, we're going to say only let the user's microservice go through. We're going to verify it using the identity properties. And we're going to do that on both sides of the connection. In this case, it's Windows, so we see PE headers, signing certificates, and otherwise. We're going to allow that to go through. It's going to show us what would be blocked. That is a simulated outcome modeled. And now we come down and we apply the change, and it will show us what is going to be blocked as a result. Now we're going to go back and do all three approaches. And when we do that, I think this is sort of like the Titanic movie. You sort of know what the outcome is going to be. You get a permission denied. This is actually an operating system error coming from LSM, error 2003 permission denied. So this is actually the Linux security module framework responding to this. And the point that I'm getting at here, and it covers a lot of things that we've discussed here. You've got an SMB v1 listener. Well, what happens? Well, if we're allowing the operating system software to communicate to that remote SMB v1 listener, the operating system client doesn't miraculously learn how to use the NotPetya exploit. It's going to be another piece of software trying to instantiate that connection, which will not be allowed either because we've detected it through our anti-malware detection or because it wasn't in the environment and we've thwarted it. They get a permission denied. Another example would be LSAS. Lots of stuff talks to LSAS. What we're doing is making sure that it's actually the right stuff talking to LSAS, verifying its identity on both sides of the connection so that the bad stuff doesn't get in and cause the problem. And the point that I'm really getting at here is that microsegmentation is a very hard problem. It's got a certain set of benefits if you do it correctly. And those benefits generally do not include identity-based verification. They include address, ports, and protocol verification, which frankly yields no protection. What we showed you here is that I can trivially piggyback through that allowed connectivity because I cannot determine what was actually making and receiving the connection. The point of Edgewise is that we get this identity information, we verify it on both sides of the connection, we build the policies for you automatically so that your user experience is you log in, You see the objects, you select them, you put it in an enforce mode. It is simulated block by default so that there is never risk to having any downtime in your environment. You go to the monitor view to see what the impact is. If there are changes that need to be made, you make those changes. Once you're confident, given sufficient time, you switch it to active enforcement and you are good to go. The last thing I would point out, since I'm 22 seconds over, is a real customer deployment. So this ML engine, which was GA'd 2 weeks ago, one of the first places that we deployed it in a production environment, they allow us to speak about it publicly, is Vonage. So Vonage is a large telco provider in the New Jersey area. They're big in Europe and elsewhere. And we met them at AWS reInvent, deployed in their environment literally over 2 phone calls and protected their environment. That is versus an industry average for a microsegmentation project from start to actual end state enforcement of 12 to 18 months. I mean, that's what automation is all about. Extreme automation, driving that simplicity to make it fast to accomplish meaningful outcomes.
So really quick question on those. If you can you say allow all but things with reputational risk? So let's say
yes. So
it comes back with one risk.
Actually, that's a really great point. The answer is yes. So very quickly, and I know, Tom, you're chomping at the bit to get rid of me here. Application blacklist. This is updated with software that either you don't want communicating in your environment or has a known bad reputation. The second you put it into this list, you can see the internal block, inbound block, outbound block. The second it goes into this list, it is wiped from communicating anywhere in your environment.
Good.
That is managed by Edgewise. So there is absolutely no reason that by default, you don't just have us looking at that identity, reputational scoring, automatically updating application blacklist and leaving all other policies not enabled. What you get from that is this software cannot communicate. It will be updated whenever bad software is identified, and the monitor view will show you all instances of that software attempting to communicate. And if you want to do forensics, literally just take this object and click on it, and it will show you what it had attempted to communicate with. And that is effectively what we do.
Yeah, are you guys strictly AWS, or can I put it in GCP or Azure?
Anywhere.
Okay.
One of our customers is in GCP. Only one. We just haven't encountered a lot that use it. Tons in Azure and tons in AWS.
Okay.